Hi, in this tutorial we have an exercise related to acid and bases. The question in the exercise is rank the following in order of increasing acidity. Let's look at the molecules and let's identify the functional groups that we have in the molecules. Okay, let's look at the first one. The first one is a phenol and the second one is an alcohol. Actually, let's write them here. The first one is a phenol. Let's write them here. The second one is an alcohol. The third one is also a phenol. The fourth one is a carboxylic acid. And the last one is also carboxylic acid. So from the identification, we can easily conclude that the most acidic molecules will be carboxylic acids, then phenol, then alcohol. Let's label them actually as A, B, C, D, and E. And since we know that D and E are both carboxylic acids, they will be more acidic than the other ones. But the question, which one, D or E, which one will be more acidic? And in order to understand that, we have to look at the substituent on the benzene ring. Here we have CF3, trifluorocarbon, and here the substituent is just hydrogen. We know that trifluorocarbon here, or like this substituent is an electron withdrawing group. So what's going to happen if we have electron withdrawing substituent? By inductive effect, it will withdraw electrons from here. Okay, so what it's going to do, it will create more acidic molecule. So basically we will say that D will be more acidic than E. And what's the reason actually? So we have actually two reasons. The first reason is this. When this carboxylic acid donate its electron, so what's going to happen? We will have a conjugate base, right? There will be a negative charge in the conjugate base on this oxygen after losing this acidic proton. So this negative charge on the conjugate base will be inductively withdrawn, and there will be less negative charge density here, and the conjugate base will be more stable or less basic. So when you have less basic or more stable conjugate base, the acid form, which is the protonated, this carboxylic acid form, will be more acidic. So we know that now out of D and E, D will be more acidic than E. Then what's going to happen? Phenols will be in the second category. Phenols are more acidic than the normal alcohols. But again, we have A and C. They are both phenol. And if you look at the substituents on the benzene ring, the first one, A, has a methoxy group, and C has trifluorocarbon. And we know that trifluorocarbon is an electron withdrawing group because of the electronegative fluorine atoms on the carbon, electron withdrawing group. And when we look at here, we have the methoxy, and methoxy is known as electron donating group because the lone pairs on oxygen will be donated through the ring through all the way to the oxygen. So this is electron donating group. And we know that electron withdrawing groups increases acidity with the same reason as I explained. When we lose this proton, we will have a phenoxide conjugate base. This phenoxide conjugate base will be stabilized by the electron withdrawing trifluoro group here. Why? Because this negative charge will be dispersed or delocalized more towards the ring and towards this trifluoro group. So it will make the conjugate base more stable and less basic, and this effect in turn will make the acid form more acidic. So then we will have C more acidic than A. Why A is less acidic? Because the effect is the opposite. The methoxy group will donate electron through the benzene ring to the uh, conjugate base. There will be more negative charge density on oxygen in the conjugate base, and it will make more basic and less stable conjugate base. Okay, then the last one will be alcohol. And as you remember, like carboxylic acids are like they have the pKa range of 2 to 4, and we know that phenols pKa range 9 to 10, and alcohols we know that the pKa range is 16, 17. So basically, carboxylic acids are more acidic than phenols. Phenols, in turn, are more acidic than normal alcohols. Thank you so much for watching the video.